champions, PU2 chemistry examination is very close. And if you want to ace the 5-marker questions, then case-based questions from organic chemistry is very important and you need to master them. So in this video, we are going to solve all the case-based questions from the 4 organic chapters given in the question bank released by the PU2 board. Okay, these questions are very important and will help you to score full marks in the section D. Okay, so let's get started with the first chapter, Haloalkanes and Haloarenes, and see the case-based questions given in this particular chapter. So first question is like this. The question is primary alkyl halide C4H9Br. Please remember the first word given here is primary alkyl halide. So if I have C4H9Br, so I will write it like this. Okay, this is the only primary alkyl halide possible. Another structure is also possible, which is like this. I can write a compound like this. Okay, two possibilities are there for compound A. Okay, reacts with alcoholic KOH to give you compound B. Okay, so it reacts with alcoholic KOH to give you compound B. Now alcoholic KOH does elimination, right? So we will get B, which must be one alkene here. Next is the compound B is reacted with HBr to give you C. Now this will react with HBr to give you C. Okay, which is an isomer of A. So you can see that this C, how it is related, it is an isomer of A. Okay, now just you can see when I'm adding HBr to alkene group, always there will be Markovnikov addition. So Br will be going to the I can say more substituted carbon, but here the Br is at the first position. So that is how it is isomer. Next, when A is reacted with sodium metal, we don't know, any one of these can be A is reacted with sodium metal. So when it is reacting with sodium metal, which reaction is this one? This is our Woods reaction. Okay, so it gives you compound D, whose molecular formula is C8H18, which is different from the compound formed when N-butyl bromide is reacted with sodium. So the D which is formed, this is different from that compound when N-butyl bromide is reacting with sodium ether. So from this we can easily conclude that A is this one and not this one. Okay, because if A is this one, then means that is your 1-bromobutane. Then if it reacts with sodium diether, it will give you octane, right? But the question is saying that when the compound A is reacting with sodium metal, whatever D it is producing, it is not that D which your 1-bromobutane will give you, okay, or N-butyl bromide will give you. Now give the structural formula of A and write the equations for all the reactions. So our structural formula of A is this one. So I will write here A structure. It is CH3 CH3, and then we have CH2Br. Okay, now when this one is reacting with alcoholic KOH, okay, then you will have a double bond here, so that will give you CH3 CH3. So this, there will be no more H here, so that will be equal to, so you can see here it will give you C double bond CH2. Okay, so this is B. Clear? Now after that, when you are treating it with HBr, so there will be Markovnikov addition. So I will have CH3 C, I can write like this, CH3 just C, then I have Br here, and I have CH3 here and CH3 here. So you can see now this one, which is the C formed here, this is an isomer of A, right? You can see here Br is present in this particular carbon, here Br is present in this carbon. So A and C are isomer of each other. Now is when A is treated with sodium metal. So that is our Woods reaction. So I will get here CH3 CH3 CH2. Now in Woods reaction double happens, means this compound will be repeated again. So I will have CH2 CH3 and CH3. Okay, so you have 1 2 3 4 5 6. Okay, so we have 2,5 dimethyl, okay, hexane. Okay, so we got here A, B, C, and this is my D. Clear? Now let's move to the next question. A compound M with molecular formula C3H6, okay, molecular formula C3H6, this is nothing but propene, reacts with HBr, okay, reacts with HBr to give you N, okay, which on reaction with sodium metal, again we have Woods reaction, produces P. Now the compound N, on reaction with reagent R gives back you M. Okay, okay. So I have to go backward this side. So what it is saying, the compound N on reaction with R yields compound M. So if I react this one with R, I will get back my M. Now compound M on reaction with X produces N. Okay, so compound M on reaction with X produces N. Write M, N, P and reagents R and X. Okay, so first of all, let's see what is compound M with molecular formula C3H6. There is only one possible structure, that is CH3CH double bond CH2. Reacts with HBr. Okay, reacts with HBr. So this is M. Now when it is reacting with HBr, it is I can say what is Markovnikov addition. So I will get CH3CH3Br. Okay. To give compound N, which on reaction with sodium metal in dry ether produces compound P. Okay, now if this one is reacting with sodium metal, okay, so that will give me CH3C, CH3, you have CH, you have CH, you have CH3 and CH3. Okay, now this is compound which is compound P. Now the compound N on reaction with some reagent R yields M. Okay, so if you see, we have to just do elimination reaction. So what can be R here? So the reagent R will be alcoholic KOH. Okay, if you react with alcoholic KOH, then this one will give you M back. Now compound M on reaction with reagent R produces an isomer of N. Okay, so sorry, not N, this produces isomer of N. So if the isomer of N will be if you treat bromine on the first position. Okay, so here what I can use HBr with peroxide. So what will that give me? That will give me bromine following anti-Markovnikov's rule. So the product here will be CH3, CH2, CH2Br. Okay, so this is what the isomer of N. And this reagent which I have used, okay, that is your reagent X. Okay, so we have written the structure of M, N, P, R and X. So M is your propene, N is 2 bromopropane. Okay, if I just want to write down the IUPAC name as well, then P is 1, 2, 3, 4, right? So I can write 2,3 dimethyl butane, 2,3 dimethyl butane. Then we have R is alcoholic KOH and X is HBr, H2O2. Now move to third question. A researcher performed a reaction of one butene. Okay, so you have one butene, CH3, CH2, CH double bond CH2 with HCl. Okay, yielded a compound A, which rotated the plane polarized light. That means this compound is optically active. Okay, it is optically active. Then he treated compound A with aqueous KOH. This compound was treated with aqueous KOH to produce a compound B. Now compound A was heated with reagent C. Okay, and reagent C to get a compound D. Okay, that was isomer of 1-butene. So this D is what? Isomer of but-1-ene. Okay, write the structures of A, B and D, A, B and D and mention the reagent C. Then what will be the optical activity of compound B? Okay, what will be the optical activity of compound B? Okay, so now let's start here. First of all, if HCl is added, Markovnikov's rule will be followed. So what will be A here? A will be CH3, CH2, CH, Cl, CH3. Okay, this is compound A, which is it? 2-chlorobutane. Okay, now we will talk about compound B, which is optically active. So here when you take aqueous KOH, so this Cl will be replaced with OH group. So you will get a compound here CH3, CH2, CHOH, CH3. This compound is what? I can say butane 2OL. Okay, next one is the D. Okay, now when compound A is heated with reagent C, he got a compound D. Now, which is an isomer? So C must be alcoholic KOH. Okay, so there will be elimination reaction, and when you do elimination reaction, Sedzif rule will be followed. So D will be but-2-ene. That is the isomer of 1-but-ene. Okay, so this is but-2-ene. So we have found A, B, and D. Okay, this is D again. I am writing here. So we have found A, B, and D. Mention the reagent C. That is also done. Next, what will be the optical activity of the compound B? Okay, now see, here this is a secondary group. Okay, now the so this can be either like dextrorotatory or even levorotatory. We don't know what it is, because that depends what was the optical activity of this compound compound A, sorry. So you can write down plus minus butane 2-ON. This will be the optical activity. It can be either dextrorotatory or levorotatory. Now moving to the next question, benzene on reaction with Cl2 and FeCl3. Okay, so first of all you have benzene. Okay, when it is reacting with Cl2 and FeCl3, it gives you compound A. That is nothing but chlorobenzene, right? This is compound A. Now, compound A on heating with CH3Cl and anhydrous AlCl3 produces B. Okay, so when you heat it with CH3Cl and AlCl3, it produces compound B. So if you know, B will be what? Friedel-Crafts alkylation reaction. So this is what? This is my Friedel-Crafts alkylation reaction, right? So that is done. Next produces compound B. This is done also. Now compound B can also be prepared from compound A by other reagent X. Okay, so how we can prepare from A to B with a different mechanism? So the first way here we can do is we can use Gattermann-Koch reaction. Okay, so you can take COHCl with anhydrous AlCl3. So that will give you, again, benzaldehyde will be added here, Cl, and you have COH. Okay, after that what you do, you then do Clemmensen reduction of this one. Okay, so when you do Clemmensen reduction, you can just treat it with ZnCl2, or you can use even I'll just write down any one, Wolff-Kishner or Clemmensen reduction, any one will work here. So I am using Zn zinc mercury HCl, ZnHCl. That is our Clemmensen reduction. Okay, and here first what we have done, this part is our Gattermann reaction, Gattermann-Koch reaction. Okay, so write the so compound B can also be prepared from compound A by reagent X. So reagent X is actually these two, comes under the reagent X. Write the structures of A and B. So A and B structures we have already written. Indicate the other reagent X. So this part comes under X. Okay, next we have name the two reactions involved in the conversion of A to compound B. So the two reactions involved from A to B is, the first one is your Friedel-Crafts reaction, then you have Gattermann plus Clemmensen reduction. Okay, now we will move to question number 5 here. In the laboratory, a student named Sanju of class 2nd PU reacted the organic compound C3H6. So C3H6, you know, it is nothing other than your propene. Okay, it has to be propene, CH3 CH double bond CH2, reacts with HBr, okay, to give you compound Y. So when it is reacting with HBr, it will be in this particular Markovnikov addition reaction to give this compound Y. Now, and later he repeated the same reaction along with peroxide to get compound Z. So when it is reacting it with HBr with peroxide, okay, that will give us CH3 CH2 and CH2Br. Okay, that is compound Z. Now he made to react compound Y with sodium metal in ether to get compound A. Okay, so this was reacted with sodium metal to get compound A. So there will be Wood's reaction here. So the product that we will get here is CH3C, CH3, CH. Then again you have the same thing, CH3 and CH3. Okay, which is your 2,3-dimethyl butane. Okay, now if this one is reacting Z, okay, so if you can see in ether to give you compound A. So this is compound A. Similarly, Sanju reacted Z, this compound, with sodium metal in another reaction vessel to compound B. So if you react it with sodium metal, so you have CH3, CH2, CH2, then again you have CH2, CH2, CH3. Okay, so this gives you compound B here. Now write the structures of X, Y. So X is what? X is, I can just write down the name here, propene. Okay, Y is 2-bromopropane. Sorry, 2-bromopropane. And Z is 1-bromopropane. Okay, and then we have A and B. So this is 2,3-dimethyl butane, whereas this one is octane, sorry, hexane. 1, 2, 3, 4, 5, 6, hexane. Clear? So these are the case-based questions from the chapter Haloalkanes and Haloarenes. Now we will move to the next chapter, that is alcohols, phenols and ethers. The first question here is an alkene. So I have taken this from question bank, so you can check the question number which is there in the question bank. Okay, an alkene XC3H6. So again here X structure we know it is propene, CH3, CH double bond CH2, reacts with H2O and H plus, reacts with H2O and H plus. So it is addition of water following Markovnikov's rule. So what will happen? CH3, CH, CH3OH. Okay, to give compound Y. Now the compound Y further undergoes reaction with CrO3 and H2SO4. CrO3, H2SO4. Now this is what? The oxidation of the secondary alcohol. So secondary alcohols oxidize to give you ketones. So that will be CH3CO CH3 to produce compound Z. So write the IUPAC name of compound X, Y and Z. So X is nothing but propene. Okay, Y is propane 2OL. Okay, this can be easily a 3-marker question, and this is propanol. And it can be mixed with 1 2-marker question. 3 plus 2, you can easily get a 5-marker question from here. Next, we'll see question number 20, an organic compound A having molecular formula C3H6. So again, we have C3H6 here. That means it has to be propene. Okay, there is no other structure possible with this particular formula. On treatment with aqueous H2SO4. So again, we are treating it with aqueous H2SO4, means water in acidic medium. So here also H and OH will be added, but following what? Markovnikov's rule. So I have this particular structure which gives on B. Okay, so which on treatment with HCl and ZnCl2. So this one is reacting with HCl and ZnCl2 to give you compound C. Now what will happen? This OH will be replaced with Cl. So I will get CH3, CH, CH3 and Cl. Okay, this is compound C. Now compound C on treatment with ethanolic KOH gives back compound A. So when you have, this is compound A, right? So when compound C, okay, see here, when compound C is treated with alcoholic KOH, it gives back compound A, right? So that means there's a dehydrohallucination reaction. Identify compound A, B and C. So compound A we have already seen, it is propene. Okay, compound B is propane 2OL, propane 2OL, and compound C is 2-chloropropane, 2-chloropropane. Okay, now let's move to the next question number 21. An organic compound A having molecular formula C6H6O. So when you have 6 carbons, okay, there's a high probability that it is benzene structure. Okay, so we have this particular phenol structure. I'm very sure it has to be this one, C6H6O. Gives a characteristic color with aqueous FeCl3 solution. So this confirms that A is phenol. Now when A is treated with CO2 and NaOH at 400 Kelvin under pressure, B is formed. So when this one is treated with CO2 and NaOH at 400 Kelvin. So this you can see, this is your Kolb's reaction. So what we produced here is salicylic acid. We get OH and COOH. This is nothing but salicylic acid. Right? This is also compound B according to the question. Now the compound B on acidification gives you C. Now on acidification, right? Okay, 1 second. Okay, so here actually this is the salt only form. Okay, so here we will just not write it like this. So B is O minus Na plus. Okay, and this is your B. Now when you do acidification, you get the final product, which is OH and COOH. Okay, this is the final product C here. Now which reacts with acetyl fluoride to form D. Now this one is reacting with acetyl fluoride, that is CH3COCl. So what will happen here? This OH will react with this group. So there is I can say acetylation or ester formation takes place. So you get a compound here like this OCOCH3, and this side we have COOH. Okay, to form a compound D, which is popular painkiller. So this is our aspirin. Okay, now write the structure of A, B, C and D. So A is there, B is there, C is there, and as well as D is there. So now let's move to the next chapter, that is aldehydes, ketones and carboxylic acid, and see its case-based question. So the first question here is an organic compound A with molecular formula C8H16O2, okay, was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B and an alcohol C. So that means A is your ester. Okay, A is an ester which on hydrolysis, I can just write down like this A, okay, and we are solving 95th question here, okay, which on hydrolysis gives you B, which is a carboxylic acid, and we have C, which is an alcohol. Okay, now oxidation of C with chromic acid produced B. Okay, so if you take chromic acid here, it will give you B here. Now C on dehydration, if I do dehydration here, so you can just treat it with H2SO4 at a higher temperature of 443 Kelvin. On dehydration gives you but1-ene. Okay, so write the equations for the reactions involved. So this ester I can easily get because you can see that C is giving you B. That means the number of carbon in B and C is same. So this is an ester of CH3, CH2, CH2, C double bond O, O, then I have CH2, CH2 and CH2 and then CH3. Okay, so 1, 2, 3, 4, 5, 6, 7 and 8. So this is A, and when it is undergoing hydrolysis, I'm getting one is B, which is CH3, CH2, CH2, COOH plus the alcohol, that is CH3, CH2, CH2, CH2OH. Okay, so this is B and this is C. Now when I have C is undergoing dehydration reaction, right? So that is, if I just react this C with dehydration, that is concentrated H2SO4, okay, that will do elimination and I will get here CH3, CH2, CH double bond CH2. Okay, this is D. I think we have got right the equations involved. Question number 96 now. So an organic compound A with molecular formula C4H8O2 was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B and alcohol C. This is similar to the question number 95. Now oxidation of C gives you B, C on dehydration gives you ethene. Write the equations or the reactions involved. So I can write down very similar C4H8. So I have CH3, CH2, CH4, right? So we have an ester here. The first ester will be formed here. So 1, 2, 1 second. I'll just write down the full formula. We have just 4 carbons, right? So we have a structure like this: CH3, C double bond O, O, CH2, CH3. Now when it is dissociating, that is H3O plus, it gives you CH3COOH plus CH3CH2OH. Okay, now what happens here? This one will undergo elimination reaction to give you CH2 double bond CH2. Alkene is formed here. Okay, now we will move to question number 97. An organic compound A with molecular formula C7H8 is heated with acidic KMnO4 to give you compound B. Okay, you have an organic compound A, C7H8. So I can predict that when you have more than 6 carbons, there's a high probability that it will be benzene ring. So toluene will be here. Now it is heated with acidic KMnO4. Heated with acidic KMnO4 and it gives you compound B. So this is compound B. Okay. Now compound B on reaction with NaOH gives you compound C. So this is compound B. Now when it is reacting it with NaOH, here there will be a salt formation, so it will give you COO minus Na plus. This is compound C here. Now, when compound C is heated with a mixture of NaOH and CO, it gives you compound D. So, when you have NaOH and CaO, this is soda lime, right? That is your decarboxylation reaction. So, it gives you normal benzene here. Okay, this is H, which is compound D here. Now, write the chemical reactions with names of A, B, C, D. So, chemical reaction we have already written. A is toluene, B is benzoic acid, and C is sodium benzoate, and D is benzene. Okay, now we'll move to next question number 100 here. A compound A, again these question numbers are from the question numbers of the model question bank. Okay, now a compound A has molecular formula of C7H8. So again I can very well predict C7H8 means it has to be toluene. Okay, now is heated with alkaline KMnO4 followed by acidification to gives you compound B. So you have alkaline KMnO4 and followed by acidification, that will give you compound B, which is COOH. Okay, after that of the molecular formula C7H6O2. Okay, now this molecular formula is also satisfied with the structure that we have drawn. Now compound B turns blue litmus red, means it is an acid. You can say you have benzoic acid here. The sodium salt of the compound B is heated with reagent X to give a hydrocarbon C of molecular mass. It is very similar to the previous question. The sodium salt of compound B, okay, sodium salt of compound B. That means I'll just write down the sodium salt first of compound B. So I will have this particular compound, that is COONA. The sodium salt of compound B is heated with reagent X to give a hydrocarbon C. Okay, to give a hydrocarbon C whose molecular mass is 78 gram per mole. So this is nothing but your benzene. Okay, and then what is their decarboxylation reaction? So NaOH CaO, soda line has to be X here. Now write the structure of the compounds A, B and C. So we have written A, B, and this is the structure of C. Identify X and mention its role. So X is what? Soda line. And what is its role? It helps in decarboxylation reaction. Okay, next 101 question. Identify the compound A, B and C in the following reaction. Okay, so first of all, A is here, the reaction is I'll say preparation of only ketone. So here the R group will be replacing the chlorine group. So I will get CH3CO CH3. Okay, then with NaOI, this is your haloform reaction. So this bond will break here. So you will get CH3COO minus Na plus, and another product formed is CHI3. Okay, the second part is important here. An organic compound C7H6O2. Again here we can easily guess C7H6O2 is there. So that means it must be benzoic acid. Okay, this is P here. Reacts with thionyl chloride, that is SOCl2, to give you product Q. Okay, that will form here COCl. Okay, now Q on the further undergoes hydrogenation in the presence of palladium and barium sulfate, okay, to form compound R. So that will give me COH. This is compound R. Now write the equations involved in the chemical reaction. We have written all the equations already. Now we will move to the next question. An organic compound with molecular formula C9H10O. Okay, you have C9H10O. Reacts with, forms 2,4-DNP. So what are the property it is given? It forms 2,4-DNP. Okay, it forms 2,4-DNP. That suggests that it is either an aldehyde or a ketone group. Now reduces the Tollens reagent. That means Tollens reagent, if it is reacting with Tollens reagent, then what I can say that it has to be an aldehyde group. And undergoes Cannizzaro reaction. That gives me an information that there is no alpha hydrogen in this particular compound. Okay, so identify the compound and write the reactions involved. Okay, C9H10O is there. So I can have like the 6 carbons are used here. Okay, then you have a structure like this. Okay, one more structure is there. On vigorous oxidation, it gives you 1,2-dicarboxylic acid. That means the substituents are present adjacent to each other. So if you have CHO and CH2, CH3, so it is 6, 7, 8, 9. 9 carbons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens are there and 1 oxygen is there. So let's write down all the reactions. The first reaction is with 2,4-DNP. So it is like this. And we have then nitrogen group, then we have here NO2 group, and we have NO2 group, and this is NH. So from here what will happen, water will be removed and you will get a structure like this. We have CH double bond NH, uh, sorry, 1 second, there's a small mistake, it's not like this. We have here, so I'll just write down this structure also, how there is elimination of water. You can see it is like this, right? COH. So what will happen, this H2O bond will be removed, so you will have CH double bond N NH, and then you have this one 2,4-DNP. Okay, that is nitrophenyl, NO2 group here and NO2 group here. That's the first reaction. Now the second reaction is with it reduces Tollens reagent. So if I react it with Tollens reagent, I have to react with Ag NH3 whole 2 plus. So I'll get this aldehyde group gets converted to a salt, COO minus, and you have CH2 CH3 plus Ag as a precipitate is formed here. The next one is it undergoes Cannizzaro reaction. So if I react it with any concentrated NaOH or KOH, so that will give me, here there will be a production of COO minus Na plus, and here it will be CH2 CH3 as it is, plus there will be reduction of the compound here to give you CH2OH plus CH2 CH3. Okay, now if I react or on vigorous oxidation, what will happen? So this both the groups will be converted to acid. So you will get a dicarboxylic acid compound, COOH and COOH. Okay, so that are the reactions involved here. Now next question, we have a compound A, just a minute. A compound A undergoes Rosenmond reaction to give you compound B with molecular formula C7H6O. So A compound is there, so that means it must be having this RCOCl. Okay, it undergoes Rosenmond reaction, that means hydrogen in presence of palladium and barium sulfate, that will give you this RC double bond OH. Okay, now you can see that there is C7, already one carbon is there here, that means 6 carbon is left. So this structure is your benzoyl chloride, that is COCl, and it one will react to give you benzaldehyde, that is COH. Okay, so this is A and this is B. We have found that much. Next is okay, next, compound B does not answer Felling's test. Yes, because it is an aromatic aldehyde, but reacts with concentrated NaOH to give you 2 compounds. So when it is reacting with concentrated NaOH, it is the Cannizzaro reaction and it will give you 2 compounds C and D. One is your COO minus Na plus. Okay, that let that be the acid form, and then it will be also giving you the reduced product, that is CH2OH, that is C and D here. Write the 2 equations involved in it. So this is the first equation and this is the second equation. Next question, we have a little lengthy one. An organic compound A on treatment with ethanoic acid in presence of hydrochloric acid gas as a catalyst produces an ester B. Okay, so you have an organic compound A, when it is reacting with ethanoic acid, okay, it gives you an ester B. So that means what? We know that when alcohols and acids react, we get an ester. So if already acid is reacting, then this must be an alcohol. Okay, now A on oxidation with CrO3 in anhydrous medium gives you C. So if it is oxidized in like CrO3, okay, it is giving you C. Now C heated with concentrated KOH, if C is heated with concentrated KOH followed by acidification with dilute, this one generates A and D. Now if you see concentrated KOH, if it is there, that means this must be undergoing a Cannizzaro reaction. Okay, and C is heated to followed A and D. So A must be again alcohol. This will be the salt of carboxylic acid. Okay, and A is what? A is the alcohol part. Now 3 moles of D reacts with PCl3, gives 3 moles of compound with molecular formula HCOCl and E. Okay, so now what is there another reaction now? 3 moles of D reacts with PCl3 to give 3 moles of a compound, 3 moles of HOCl plus E. Okay, D is reduced to A. Okay, D is reduced to A by lithium aluminium hydride. Okay, that means here D and A is having same number of carbons. The molecular formula of A, B, C and D. Okay, so if I see that, this I can easily guess HOCl is produced, that means this D must be HCOOH. Okay, so then when I treat it with PCl3, I will get HCOCl. So I have found out D here. D is HCOOH. Okay, and A is an alcohol, so A must be this one, that is CH3OH. So I can just write down methanol, CH3OH. Okay, A is methanol. Now when methanol reacts with ethanoic acid, so the ester will form here. So this is CH3OH. So the ester formed B will be an ester which will be CH3OCOCH3. Okay, this two will react to give you this ester CH3CO. You have then OCH3. Okay, so that is your ester formed B. Now C is what? This one, when it is oxidized, this is a primary alcohol, and with say CrO3 it will be oxidized to give you an aldehyde. So C is your methanol, HCOH. Okay, it is methanol. Now on treating it with concentrated KOH, you get one is the salt HCOO minus Na plus, that we get here, and an alcohol, that is HCH2OH. One second. This will get salt. So this is actually the carboxylic acid part, and A is the alcohol. C we got, A we got, and now we have to find out E here. So when PCl3 reacts, the byproduct formed is H3PO3. Okay, so that will be the reactant here. Okay, so we found out A to E. Now let's move to the question from amines here. An organic aromatic compound A on treatment with aqueous ammonia followed by heating. So you have an aromatic compound A, okay, on heating with aqueous ammonia followed by heating forms compound B. Okay, this we don't know. Okay, just the aromatic compound. The compound B on heating with Br2 and KOH. Br2 and KOH forms the compound C. Okay. Next is next we have C with the molecular formula C6H7N. So we can easily guess that this one is NH2. Okay, because C6 is there, H7, 1, 2, 3, 4, 5, 6, 7 and N. So IUPAC name of C here is aniline. Okay, now this one is Hoffman bromamide degradation, so you need to have this one CONH2. Okay, so its name must be benzamide. Now this particular group we will get if I have benzoic acid, COOH. When you treat it with NH3 you get CONH2, so its IUPAC name is benzoic acid. Okay, next question. An amine A can be prepared by Gabriel thalamide synthesis. That means A must be a primary amine. The compound A reacts with nitrous acid to give an compound B. Okay, so it reacts with nitrous acid to give you compound B. The functional isomer of B is CH3OCH3. That means what? This B is an alcohol. Okay, if this is an alcohol and on treating with nitrous acid we are getting an alcohol, that means this is an aliphatic amine. Okay, aliphatic primary amine. The compound A can be prepared by the reduction of amide C. Okay, if you reduce the amide C, okay, then we can get here compound the one second, A can be prepared, yeah, if I reduce it, reduction of this amide will give me A. So identify this compound. So if this is a functional isomer, so if this is an isomer of B, then this must be CH3 CH2 OH. Okay, now this particular then amine must be CH3, CH2, NH2. Okay, now if I want to reduce it from this amide, then it must be what amide I can take here? CH3, CONH2. Okay, now if this C is treated with lithium aluminum hydride, you will get CH3, CH2, NH2. Identify the compounds A, B, and C. So A is your ethylamine, B is ethyl alcohol, and C is ethanamide. Okay, now see, let's see the next question. A hydrocarbon A with molecular formula C4H8 on treatment with hydrochloric acid gives a compound B with molecular formula C4H9. So you have A here. Okay, so hydrocarbon A C4H8 on treatment with HCl gives a compound B. Okay, whose formula is C4H9 and Cl. The compound B on reaction with 1 mole of ammonia, okay, gives a compound C. Now the compound C with nitrous acid followed by the reaction with water gives an optically active alcohol D. Okay, this is optically active. Now the ozonolysis of A gives 2 moles of acetaldehyde. So if we have O3, it gives you 2 moles of acetaldehyde. Okay, now identify the compound A, B, and D. So we have C4H8, it is CH3. So if it is giving 2 moles of same compound on ozonolysis, then we need to have a symmetric alkene, right? So this is but2ene. Now on treating with HCl, you will get CH3, CH2, CH3, and here you have Cl group. Now on NH3, if you treat, this one will get converted to I can say, one second, there is no mention of HCl, right? Okay, so this one will get converted to CH3, CH2, CNH2, and you have CH3, CH3. Now on treating with nitrous acid, this gets converted to alcohol, CH3, CH2, COH, H, and CH3. Okay, so this is an optically active alcohol is formed here. Now on ozonolysis, this will break here and you will get 2 molecules of CH3COH. Okay, identify the compound A, B, and D. That's how the reaction will take place. So children, these were the most important, I can say, the case-based questions from all the 4 organic chapters. If you have any doubt in any question, do let me know in the comment section. Thank you so much for watching and all the best.